Hello and welcome to today's webinar, Designing Modicon 580 Architectures for Data Transparency, Enabling Top Floor to Plant Floor Data Accessibility. Thank you for joining. Before we are about to start, we would like to cover a few housekeeping items. We'll be running a live Q&A during the presentation. If you have any questions during the webinar, please click on the Q&A panel at the bottom right or enable this feature on the three-dot icon on the slide area and submit your question. We will try to answer these during the webinar, but if a fuller answer is needed or we run out of time, it will be answered later via email. We do capture all questions. I would now like to turn the conference over to our presenter. Thank you. You may begin.
Awesome. Thanks, Emmy. So thanks everybody for joining. Today's Modicon User Group is about network transparency. And joining me today is Jerry Bartolome, who will do the grunt work of our presentation, and he's prepared a great one for us today. And David Baker will be standing by for any questions that you may have. And as Emmy had mentioned, please direct your question to the Q&A box. There's a chat box, there's a Q&A box. We all know the difference, but it kind of keeps all our questions together and answers together if we do it in the Q&A box. I will put some stuff in the chat box as we go along, and I'll explain it. Just real quick, if you go out to Google and you want to, Google network transparency, you're not really going to find much. That's a Schneider Electric term. And simply, it's based around the features that we have in our M580. Those of you who are using our stuff probably know this. Those are not. It might be new. We have an Ethernet across the backplane. It allows us to be able to, Ethernet devices that are north of the PLC, such as maybe SCADA systems, data analytics, asset management type systems. They can go down, they can reach through the PLC in one port, go across the network and the backplane, and then go out another port without involving the controller at all. So it involves some special networking and routing capabilities, and we kind of want to go through that with you today. So Jerry Bartolome, David Baker are our system architect experts, and they're going to join us today and go through it. Before we do that, we're going to, as usual, Modicon User Group, we focus on these items today. It's really about networking, but it also brings in the HMI and the PLC portion of stuff. I will put in the chat our YouTube playlist. My entire team puts together videos to make our stuff easier to use. And, please go ahead and bookmark this YouTube playlist. We have plenty of videos out on the internet, but this is specifically for my team. Connect with me on LinkedIn. I post this video when we're done, probably about 2 or 3 weeks, probably right after we get back from the holidays. We will post this and all of the videos that we've had over the course of the year on my LinkedIn page. Again, as Emmy had pointed out, please direct your questions to the Q&A. If you want to know more about this particular one or any Modicon User Group, please feel free to contact me. And then lastly, at the end, as we do on almost every Modicon User Group meeting we have I put a survey in the chat, and that survey helps us get better. It's real quick. It's just a, hey, how do we do today type of presentation, and is there anything you'd like to see on future presentations? With that, we do have a special guest today. Our special guest is Grant Van Hemert. He is our product marketing manager for our PLC business. And so he'd like to come on and talk a little bit about what products have been released recently and what you could expect coming in the first quarter of next year. And so, Grant, let me go ahead and turn it over to you.
You're welcome. And so let me set this up to share. And I think now you guys should be seeing my presentation.
We got it.
I've got a couple of things to go over, not much. One thing that I'm actually really excited about, but let's talk a little bit first about some recently launched products. There's one we put out there, and the feedback that we've got is that people weren't even aware that this was out here or that it's a little bit different than what we already had on the market. And this first one is a new DDO offer, a 32-point DDO output. So the big point here is that this is 32 channel, and we've got another 32 channel offering on the market, but this happens to be a 0.5 amp per channel. And I believe the other one on the market is something like 0.05 amps. So this is definitely a much more robust card, and it helps to enable us to provide a better migration from quantum over to the M580. So this is just another tool to help move in that direction. So the next thing that came out is a new version of Process Expert. And probably the biggest thing here is that there's more languages than just English supported in it. Now, the rest of it is just a normal update. There's just been some enhancements and some tweaks as we go along. Now, if you're not familiar with Process Expert, what this does is it's a software that tightly integrates in with Control Expert, as well as with our Aviva SCADA offerings to bring a lot of synergy together as well as you're developing. So you're kind of developing both at the same time. Kind of a neat product. So coming soon in 2024, we have a 16-slot X-Bus backplane. There's not an Ethernet version yet on this. It's just a non-Ethernet version coming out. But once again, for you guys that are looking at migrating from Quantum over to M580, this is yet another tool, because now we've got a 16-slot rack to match the 16-slot rack we had in Quantum. And then with the 32-point cards we're coming out, we can start to really optimize and make sure that it's a one-to-one replacement. So one of the other things is this RTU module that has come out. For those of you that are using IEC 60870 or DNP3, this new version has Ethernet ports on the front. There was a BME version out before that did not. And there's also a BMX version for the M340 that's out there. This one is specifically for the M580. So if you're using DNP3, chances are you're going to use M340s out at your remote stations, and then you would use a M580 at your main station, and this would be the solution to allow you to tie in. We also have a new version of EcoStruxure Control Expert coming out this next month. Most of the upgrades within this are in regards to the new products that are coming out, but certainly there is some enhancements to some stuff with the M580. There's some faster online changes and some other just nice tweaks and stuff that we've put together just to make it a little bit easier to use and a little bit more responsive. This one is actually kind of neat, and I'm not really going to go into it. This is coming out on a limited release, so if you have the need for this module, and I'll tell you what it does in a little bit, you're going to have to work with your sales application executive or your SAE to figure out if this is a good position. Now, your question is going to be, okay, great, you've got this edge compute module. What does it do? And believe it or not, that is probably the hardest answer for me to give. And that is because what this is, it is a development environment where you can put what you want to put into here. So it offers a lot of capability. So for instance, maybe you're using a network that we don't have a network card for. Okay, now this ECN module is out there. You can create that network driver, and boom, now you can adapt our M580s to work with that new network, even though we may not have a card out there for that specific network. Do you have some routines that you may work on in an Excel platform, and instead of having to pull up Excel and pull the data out of SCADA, you'd rather have that routine work live within the PLC environment? Here you go. This is your way to do all that. So there's a lot of capability here and a lot of power to develop your own unique things where you've just been able to go, gosh, I just wish I could do this in a PLC. This is the answer to that question. And those really are some of the biggest updates that we have. And so I am going to pass this whole presentation over to Jerry Bartlemy. So thank you. And if you have any questions, please feel free to put them in the Q&A. Jerry?
Thanks, Grant. I'll get my screen shared here. So thanks for coming, everybody. So this is all about, like Lou mentioned, all about data transparency, making sure that we have the ability to get data from the plant floor from the field devices all the way up into our apps and analytics layer without involving an intermediate gateway or intermediate piece of middleware. But first, there's a little bit of background we need. So with the M580, a lot of this is predicated on the use of the Ethernet remote I/O system. That's how we're connecting to all these field devices. So we're going to do a bit of a review here for that. Our Ethernet remote I/O system is based on an Ethernet IP RSTP ring. RSTP is Rapid Spanning Tree Protocol, and it gives us the ability to have a ring topology. It actually gives us the ability for other than ring topologies, whether it's star or mesh or other things like that. But the ring is by far the typical implementation here. And the other thing that RSTP does is that it provides a redundant path for messages. So the CPU up here is sending out a message either over the top port or over the bottom port to any given drop. And RSTP is what determines which port it goes out and how that is managed. And it does that by figuring out what's the shortest path to each drop. So it's kind of a no-brainer here. For this first drop, it's going to come out the bottom port. For this drop, though, it could come out through either the top or bottom port, and RSTP will manage that for us. It also manages recovery if there's a problem in the network. So if we break a cable here, let's say that we break this cable right here, or the switch dies down here. That means that any messages coming from the top port to that second RIO drop are going to be lost. And so RSTP will sense that through the loss of the link and reestablish a path for those. So this recovery time is less than 50 milliseconds for the M580, even on a very large remote I/O system, a full 31 remote I/O drops. So it's very efficient, and we like it a lot. The other thing that makes this remote I/O as opposed to distributed I/O, remote I/O is inherently part of the CPU's configuration. And so for us, it's configured with an EcoStruxure control expert, as opposed to just messaging out to devices, to I/O drops. And so that's something the M340 would do since it doesn't have remote I/O. Now we can do that with the M580 as well. But with remote I/O, it is integral to the processor and integral to the processor scan. It's handled by the operating system. There are a couple of components to this system. So the ring ports themselves, these are the bottom two ports on both the CPU and the Ethernet remote I/O drop adapters. So these are what we connect to the RSTP ring for the Ethernet remote I/O system. So what can belong to that ring? Obviously, these two devices, the X80 remote I/O drop adapter, but also Quantum remote I/O drop adapters. We have dual ring switches. These switches are special Modicon switches that allow you to come off with another ring of either distributed devices like VFDs or smart starters, or a ring of Ethernet remote I/O drops. So giving us the ability to really change our topology. The next component of this is the top port of the three ports. So this is called the service port. So this does not support Ethernet remote I/O drops directly, but it is part of the Ethernet remote I/O system. It supports Modbus TCP or Ethernet IP messaging from the controller or from any of the communications modules. And it supports actually all TCP IP protocols. So anything can pass through that port. Certainly those that are used by the CPU, but when we get to start talking about transparency, it could be other protocols as well. We can program messages to be issued from the CPU from either the CPU service port directly or from the service port on a remote I/O drop adapter. So there are two methodologies. The first is explicit messaging. So explicit uses instructions like read var, write var, data exchange to send a message out. And so in this case, we are a client and we are initiating a message out to another device using Modbus TCP, Ethernet IP, or OPC UA. There's also, and of course, through those ports, we can act as servers as well. There's no programming involved with that. If we receive a message, we just respond to that message. Implicit messaging is a different methodology. So this is more configured than programmed. And so we use in the M580 what are called DTMs. These are device type managers. And device type manager spec is defined by the FDT.org organization. This is an open standard that's adhered to by many manufacturers. We use DTMs as essentially software modules that we plug into EcoStruxure Control Expert and hence into the M580 that give us connectivity to some of our own modules, but also field devices as well. And we have communications DTMs that allow us to just issue generic Modbus TCP or Ethernet IP messages. So through this methodology, we can act as a Modbus TCP client. We can set up Ethernet IP messages as a scanner or actually as an adapter as well, and do all of these concurrently in the CPU or an NOC module, one of our communications modules. So the number of devices that we can actually send messages to varies by the type of processor, whether it's explicit or implicit messaging. If it's explicit messaging, it could be anywhere from 16 to 64 concurrent messages per scan that are active, depending on the processor level. If it's implicit messaging, that's more tied to the Ethernet coprocessor in the field devices, in the controller, or in the NOC module that's initiating those messages. So in an NOC module, the communications module, it's 128 transactions. Part of those are reserved for the Ethernet I/O adapter, what we call local slave there. And on the CPU, if it has remote I/O capability, it's a total of 64 transactions, or 128 if it does not have remote I/O capability. Because we have models that either do or do not have remote I/O in the M580. Now, on the service port, we do limit messaging bandwidth there because the communications to remote I/O drops are of prime importance, and so they get almost all of the bandwidth. So we limit bandwidth to 5 megabits per second on the service ports on the ERIO drop modules. Now, that sounds like it's limiting. It really isn't. That's actually quite a bit of bandwidth because the messages we're sending really aren't very large, and we can send an awful lot of them concurrently on 5 megabits per second. So let's talk about how this system actually operates. So this is the same methodology for either Ethernet remote I/O, setting up a remote I/O drop, or for FDR, or fast device replacement. And this really isn't an FDR discussion, but if you're familiar with what it is, this is managed the same way. All right, so when a drop adapter first powers up, it sends out a DHCP message. DHCP is Dynamic Host Control Protocol. And what it is a way for a device to announce itself on a network and request an IP address from a DHCP server. In this case, the DHCP server is the M580 CPU itself. This is it's an ASCII character name that we send out. And in this case, the CRA module, the drop adapter, has a fixed naming convention. So it's BMECRA _ and then 3 digits that represent the drop number, which is right above that laser pointer are 2 address wheels. And those are set, if it's drop 1, they're going to be set to 0 on the left and 1 on the right. And the DHCP name then for that drop would be BMECRA _ 001. So it powers up and it sends out a DHCP message request. And the CPU says, okay, I have an entry for this DHCP name in my table, and I'm going to send out an ARP request. So ARP is Address Resolution Protocol. And so what we're looking for is to see if the IP address associated with that DHCP name already exists on the network, because we don't want to duplicate it. That causes problems on our network. So it sends out an ARP command for the configured IP address. So do you exist out there? If nobody responds, we know that it's not configured anywhere else. And then we send that IP address down to that module. Once it has an IP address, then we can use FTP, File Transfer Protocol, to send it its configuration. Then we're off and running. It goes into run, and you have a fully operating remote I/O drop. If we connect a CPU to the plant network by its service port, let's see how that works here. So when our drop powers up, it sends out the DHCP name. Now, remember I said that the service port is part of the Ethernet remote I/O system. And so DHCP is a broadcast protocol. It's going to go everywhere it's allowed to. And that means it's going to go out of that service port. It's going to go up to the plant network, and the whole network is going to see that DHCP request. So we're treating this as if we only have one M580 on the plant network at this point. It sends out the ARP request, who has that IP address. If no one responds, then it sends the IP address down to the CRA module, and it sends its configuration after that. Now let's add another M580 here. If the M580 drop on the right is also configured for drop 1, and it powers up, it's going to send out a DHCP request. The service port on that M580 is also going to broadcast that DHCP request. And so the CPU on the right sees it, but it also broadcasts that, and which means the CPU on the left is also going to see that same request. Both of them have entries in their DHCP table for drop 1, for BME CRA 001. So what happens? Both of them send out ARP requests for the IP address. Now, what should happen is that the CPU on the right should see that that request is not satisfied. Nobody else has that IP address, so it's going to send down the IP address to this drop, and then its configuration. However, depending on where these CPUs are in their scan, that might not be the case. So it's possible for the CPU on the left to actually send its IP address, which will be now the incorrect IP address, to that drop, and then send its configuration. So now what you have is two remote I/O systems which are intermingled by connecting them to the service ports on the M580. And the possibility exists that this could happen. And in fact, it has happened. The most common occurrence is we have a power outage in a plant, and when everything comes up, things come up in kind of a random order, and it's entirely possible for a remote I/O drop on one M580 to be configured by a different CPU than it should. That's a situation we don't want to have happen, and that's why we recommend that you never connect the service port of an M580 to the plant network. Now, there are ways of getting around this. When I say getting around, there are exceptions to this, and those exceptions are highlighted by a white paper that we'll talk about at the end. That's up on se.com. The preferred method that we have is connecting by way of an NOC module. NOC is network option, combined protocol, or I hear different readings for what the C means, but essentially it's our communications module for the M580 on Ethernet. And it supports Modbus TCP and Ethernet IP messaging. But the key element here is that we can connect the plant network to this, and it actually connects and passes data to the CPU by way of the serial backplane, not the Ethernet backplane on the M580. And so that means we can disable the Ethernet backplane port and decouple this module from the Ethernet remote I/O system. That's very important. And so now what happens? The drop is powered up. It sends out its DHCP message, and it is not passed on by the NOC module to the plant network because it is isolated. It's not actually on the Ethernet remote I/O network. And then the IP address assignment and the configuration goes down to that drop. If we add a second M580 and connect it in the same fashion, then the same thing happens. Its DHCP name stops at the CPU, doesn't go to the plant network, and then it gets its proper IP address and configuration. So this by far is the easiest way to manage this scenario. So that brings us to now the discussion about transparency. So transparency is a primary philosophy of EcoStruxure. So it makes it possible for data from the business side of the network, or even from, say, an asset management or a web browser that's sitting on the plant network, to get down to the field devices directly. Now, historically, what has happened is that those messages had to come through from the plant network. A request for data would come down into an Ethernet module, and the CPU would typically act as a data concentrator. So it would have to request data from the field devices and hold it for that asset management system, for SCADA system, for historian, for process optimization software, what have you. Meaning there's additional work and additional loading on that CPU over and above the control task that it's doing. But one major innovation in the M580, probably the major innovation, is the addition of an Ethernet backplane. So that extends the Ethernet remote I/O system to the backplane of each rack in the system. And that gives us great capabilities. So now that NOC module that we had a couple of slides ago could be connected to that module, connecting the plant network to the Ethernet remote I/O system, and then getting access directly to any of these field devices without the processor's intervention. And so that NOC module is an active switch. The backplane itself is an active switch. And then the drop adapters are active switches and their backplanes as well. And so now you have just data passing between switches. However, this begs the question, if I'm connecting my remote I/O system up to the plant network, how do we do that without intermingling those remote I/O systems the way we showed before? So there are several methods we can use to do this. The first method is to use a layer 3 switch. Now, some of my customers I know are using layer 3 switches as standard through the plant network, but most of them are. However, the beauty of a layer 3 switch is this provides routing between anything up on the plant subnet down to any device in our Ethernet remote I/O. And in that case, we need each one of these to be on a separate subnet. So each of these remote I/O systems would have a different subnet. In the example I showed before, which is the NOCs isolating it, you could leave everything at default. So the default IP address for the CPU and for the remote I/O system is 192.168.10.1 and 11.1. So that could be the same for every M580 in this system. However, for transparency, we can't do that. We have to have different subnets for each of these so that we know how to route a message from something on the plant network down to something in a specific M580's remote I/O system. Now, we recommend the use of the layer 3 switches if we're dealing with very large applications. And the reason, you'll see the reason for that in a minute, but basically it's pretty easy to set up routing tables in the layer 3 switches to manage routing of the messages to the specific subnets that are connected to it. And that can be done from a central location. The other beauty of this is that a layer 3 switch will block broadcast messages. And so the DHCP message that comes from this CRA module and would get broadcast out the service port will be blocked by this layer 3 switch and not make it to the rest of the network. And so that effectively isolates the remote I/O systems from a configuration standpoint, which is the main goal of the first part of this discussion. But it still allows access of any specific message going to a specific IP address on a field device. The second method, and we see this very commonly, is the use of the NOC control module. The NOC control is the BME NOC 0321. You'll see this part number on a slide in a second here. And so that would be this module on the right-hand side. So it has the ability to provide some routing functionality. So it uses IP forwarding and uses that to set up 2 or 3 subnets that it can connect to and route between. So we have the control network, which is the network ports, the ring network ports on the face of it. We have the device network, which is the backplane. That's the Ethernet remote I/O system of this M580 and everything that's connected to it. And then we have the ability to segregate out the service port and give it an additional subnet of its own called the extended device network. So let's talk a little bit more about that module. So it's a cyber secure module. It's as much as any component is in the M580 system. And so it's the most cyber secure one of the most cyber secure systems out there, and getting more cyber secure by the day, it seems like. One unique feature of this module is that these ring ports down here support 1 gigabit networks. And so if you're connecting them to a plant network directly, that's 1 gigabit, which is happening more and more frequently. These are configured for RSTP. So, we can create a plant network around that and basically just daisy chain our controllers as part of that plant network, or connect them up to a switch, which is most common. So if we don't have IP forwarding enabled, we really only have one subnet, and that subnet is the control subnet. So essentially the NOC 0321 acts like a NOC 0311. So that's the factory cast version of the NOC modules, and allows a lot of customization from web pages and some diagnostic viewers on it. So it's a very nice module, but the NOC 0321 acts just like that if we don't turn on IP forwarding. And so that means the front ports and the backplane port are part of the control network. And the way we configure that is to go into the module configuration in the IO map. And so set up our main IP address. So in this case, you have one IP address that you can configure. You have a subnet mask, and then you have a gateway for it. If we turn on the backplane port, enable the backplane port, now we can enable IP forwarding as well and create two subnets. So that segregates the control network on the front of the module from the device network, which is on the remote I/O system in the backplane of the rack that this module sits in. And then we can route messages between those two subnets. So the way we manage this is we go into the DTM for that NOC module in the DTM browser. And in the switch setting, we turn the backplane port on. We say yes. This defaults to no. We need to specifically enable that backplane port. The next thing we do then is go to services and enable IP forwarding, which by default is disabled. There's no point to it if the backplane port is disabled, right? So it's not enabled by default. And then the third thing we do is come now applying that. We now have an IP forwarding service that we can come in. And this field bus network here is the device network that we're talking about. So this is the Ethernet remote I/O system connected to the backplane, and give it its IP address and subnet for that system. Now the subnets, don't have to be the same. These are independent network connections, and so you're going to have IP addresses on different subnets with different subnet masks for these. Now we can turn on extended device support and create an extended device network subnet, and that would attach to the service port. So back into the DTM or the NOC module again, we come back to the service port configuration, and now that we have IP forwarding turned on, we have for that port configuration, we have extended network as an option. And so if we select that, now we've just created our third subnet. And when we come back to the IP forwarding page, now we have the last information that we need, which is we can give it the IP address for that NOC module and the subnet for the extended device port. Now let's take a look at an example and how this actually works once we do this. This is an eye chart, right? So let's look at the NOC 0321. That's the module on the far right. It has 3 IP addresses assigned. So the control port, 135.13.47.116. Those are the 2 ring ports here, and we're connecting that up to our plant network. That's on the subnet for the plant network. The device network. So this is on the remote I/O system. Okay? So 192.168.12.1. And out here, we've got a NOC module. This NOC module is on that same subnet. And it has this backplane port enabled, but it is not connected to the plant network. Right? So that means the front ports are also on the same subnet as the Ethernet remote I/O system. And then we can attach, say, this VFD to that, do implicit messaging out to it, but also allow access for messaging from the CPU, direct messaging, or from things up on the plant network. And then we have the extended device network. That's our 10.1.22.121. And here that's on the service port. We have a TSYS-T connected in that 10.1.22 subnet. Now let's say that we have an asset management computer up here. It's sitting at on the node 5 on the subnet for the plant network. And it wants to get a message down to this TSYS-T. It wants to look at a web page on it. And so how does it, or configure it and check things. So how does it do that? Well, it needs to have, first of all, it needs, for that message, it needs for the gateway to be this NOC module. Well, in order for that to happen, if you've got 15 M580s out here, you're going to have 15 gateways depending on what message you're trying to send to devices on those 15 controllers. And so we use a route statement. So this is a command line statement that we make and add these elements into a routing table in that PC. So it's route add, and then the subnet range that we want. So 192.68.0.0 is the subnet range for our remote IO system. Okay? In this case, the device network. And then we add one, the 10.1.22, with a mask, subnet mask that's appropriate for our extended device network, where this TSYS-T lives. And then the gateway address, in order to get to any device that are in these subnets, we need a gateway address for it to send the message to. And that is the NOC 0321's IP address on the plant network subnet. Right? So now it knows if it wants to get to 192.168.15.13, it knows that it needs to first send that message to this NOC control. And the NOC control will route the message automatically to the device network, where it will be picked up by the NOC module and end up with the Altivar. So it's a pretty simple configuration. One of the reasons we say that the use of the NOC control module is best probably for small or medium-sized networks is that you need to have these route statements in each of the PCs that are on that subnet that need to get to these devices. And so that can be a daunting task if there are lots of PCs and lots of PLCs out there that we're managing. So that can be done through a batch file. You don't have to literally type it in to a command line interface, but that batch file could be set to run on boot up of that PC. So it's not really a big problem, but it's probably not as easy to manage for a lot of organizations as it would to have a layer 3 switch out here and have the routing table for this controller or the controllers connected to it in the layer 3 switch. A third option is the B&B NUA module. And so this module is our most recent addition to the networking module suite that we have. It's been out a couple of years now, 2 or 3 years. And this, the ostensible reason for this is to accept OPC UA messages from a client, say a SCADA system or a DCS out there that's able to send OPC UA requests, and then accept that and use those messages to get variable data from the controller. So we're not using Modbus, so there's no Modbus addressing involved. Everything is by tag name here. However, this also responds to Modbus TCP and Ethernet IP messages, so it's a full COM module. And we can connect to the front port on this, the control port, and connect to the Ethernet backplane. It has IP forwarding built in by default. So let's take a look at that module a little bit. So it supports 1 or 2 subnets. If it's one subnet, that is actually the backplane subnet. So it's the control network on the back, or the device network on the backplane. If you turn on the control port, then it provides IP forwarding between them. So it has probably the best cybersecurity that we have, because on OPC UA, that's all certificate management that's done to manage security for the secure version of OPC UA. But it still supports IPsec tunneling for non-OPC UA messages. it has all of the access control list and all of the things that you would expect a comm module in the M580 to have. The front support works, and it supports IPv6 addressing. So it's the only module we have in the M580 right now with IPv6 on it. So if we turn on the control network port, then we also have IP forwarding, and we can provide our transparency functions. So when we do this, we just open up the module in the IO map, and we give it its, the backplane port is the device network and is its primary network actually for the OPC UA module, and we give it the appropriate IP address on the remote IO subnet. So in order to send an OPC UA messages with the front port not enabled, then we're sending those across the backplane. So those are coming through a NOC 321 or a standard NOC or something like that, and bridging across the backplane to get to this module. If we turn on the control port in the front, now we have an additional set of IP addresses we can give. It's IPv4 and or IPv6 can be configured for this module. And then this would be the subnet that is connecting to the control network to the plant network in this place. And IP forwarding is automatically turned on when you enable that control port. So this again is an eye chart, very similar to the NOC 321, except that we only have 2 IP addresses for the NUA module, not 3. And so routing of messages works exactly the same way. To get a message to something on the device network on this M580, we need a route statement in this PC that sends anything in that subnet to the IP address for the for the NUA module sitting on the plant network. So it's control network IP address. And then it automatically will route that message to the backplane and out to any field device that's on that subnet. And like the NOC 321 and like a layer 3 switch, both of those are going to block any broadcast messages and isolate the remote IO systems from each other. So in summary, it's become very important to do this. We have so many intelligent devices out there now that we're starting to take advantage of, not just for data, but for configuration capability. An easy example would be having Hart field devices connected to our Hart analog input and output modules, and using transparency to connect an asset management system to those devices directly to manage them, to configure them from a central location. Now it becomes very easy for a maintenance computer to open up a web browser and connect to a VFD's web page, for example. And so more and more we need for this type of transparency. So it's built into the control system in the M580. So it becomes very easy to implement this. We need to make sure that we balance our cybersecurity needs with that. And the M580 is designed for that as well. And so it really becomes a pretty simple task to make sure that we not only have access of data everywhere it needs to go, but in a secure fashion. So this really is one of the main reasons that the M580 ePAC is one of the best ones out there. In a complex plant environment, there's so many things that we need to take into consideration, and the M580 is built around all of those needs. So the Ethernet core functionality that it has is extremely important in achieving this, because we're moving more and more towards an all Ethernet environment. We have some resources. One of these is a white paper I've written on successful M580 architectures. This presentation that I just gave is a subset of that white paper, and you can find it on se.com. If we go there and we type in M580 architecture into the search bar and just scroll down, we find that under the documents list. So I would encourage you to download this and read it. This is not the updated version that has the NDOA module in it. If you need that one, then please get a hold of your SAE, your application engineer locally, and they can contact me to get that, or they may already have it. The other resources there are standard M580 resources. And so if we look just for the M580 on here, we're going to see the M580 PAC controller. You'll get all the information you need in the documents here. The cybersecurity documents are part of this as well, and they're really quite important documents. So yeah, I would recommend looking at these two documents from a cybersecurity standpoint. They're very important when it comes to laying out a system and making sure that you're taking advantage of all of the cybersecurity that we offer in all of our devices, not just the M580.
Jerry, that was awesome. Thank you very much for your presentation, and thank you for David in the background for manning all the questions. It looks like most of the questions were answered. We do have one that's outstanding here. Which control mechanism of the NOC 321 is used to avoid someone to configure routes on an undesired device and send messages through the network?
So that would be part of the access control list that's in the NOC 321. So you can tell that device or that module what IP address, either subnets or what specific IP addresses it will accept messages from. And so you can come down. Now that doesn't mean that you can't have an internal disgruntled employee or something go onto a PC that is allowed on that list, say a SCADA PC or a maintenance PC, and perform that action. But it will restrict access to only those devices that are allowed to connect to that controller.
Awesome. Thank you, Jerry. It does not look like all the other questions were answered in the Q&A. I would like to mention again, please take a look at your chat. I put a survey in over there. It really helps us to get better. We do that on almost every webinar that we have, and we read every single one of them. So please, it takes a minute to do. It's anonymous, but we do have a question in there that if you'd like to know more about this technology that we have or any of our solutions, feel free to leave your name and number, and we'll have somebody give you a call. Other than that, that concludes our Modicon User Group webinars for 2023. I appreciate, like to thank all our audience for attending and making us actually one of the most successful webinar series for Schneider Electric. So again, thank you very much. Wish you and your families a happy holidays, and we'll look to see you again in February. We'll be on next webinar. Thank you, everyone. Have a good day.